Okay, look at example 1. Given the function we plotted here, so this is a function y equals fx. So all the 4 points you can easily find out the coordinates, so I listed here. And then to sketch them, you just need to find out all these key points, their corresponding points of this 4 on its inverse. So it's very easy to find out the corresponding point of the inverse. You just reverse the 2 coordinates. So -4, 4 becomes 4, -4. And for the point B, because the 2 coordinates, they're the same, so even you switch, you still get the same thing. So B is actually an invariant point between the 2 inverse functions. And then C 1, 3 becomes 3, 1. D 3, 2 becomes 2, 3. And then we can plot all the points here. 4, -4. So we got A prime here. And B is -1, still here, still the same points. Okay. And C is 3, 1. 3, 1 right here. And D is 2, 3. 2, 3, 3, 2 becomes 2, 3 right here. Okay, I've got to label this. So this should be C prime. This should be D prime. Okay, just connect all the points. So starting from A, then to B, and then B to C, C prime, and C prime to D prime. Okay, so this is actually the function of f -1 x. Okay, we're done. And the question asking, is the inverse a function? Okay, now we know that function, you have to pass the vertical line test. So if you draw a vertical line here, you can see you're going to pass the function twice. So then it's not a function. Okay, so this no. Okay, because you can't pass the vertical line test. Okay, and then another thing about this inverse is that, you know, if you draw a line from here, if you draw this line, go through this. So this is actually line is y equals x, right? Now you can see all the points, they're symmetrical about this point. So A is symmetrical about this line to the A prime, right? So because you switch all the points x and y, you can, if you're interested, you can actually prove, you know, use geometry. See, for example, it's easier to do the point C and the C prime. You can see if you connect these two points, right? If you connect this and you connect this, we have to if you connect this, you form the 2 triangles, right? 2 triangles. This 2 triangle is supposed to be congruent, so that's why these 2 lines, they're equal, right? So that's why the C and the C prime is symmetrical about this line. So that's another clue. If you want to draw and sketch the inverse, you just find out some key points and reflect on this y equals x line, right? But easier way, if you already know the coordinates, just switch the x and y axis, right? Okay, and state the domain and the range of both. And if you look at how the inverse is drawn, actually just switch and the domain and the range. That would be the domain and range of each of them. So let's first look at it, fx. Fx a, b, c, d. You can see the domain x is between -4 and +3. So and then the range y is between the lowest point is here, so between -1 and highest point is a, so that's 4. And then for the f -1x, so you can just simply switch them. So the domain of the original one would become the range. So y is gonna be -4/3, right? So you can see it's the same, and this range of fx will become the domain of the inverse, right? You can easily verify the domain right now is from -1, that's the most left point, to the most right point is 4, and then range is lowest point is a prime, so -4, up to the highest point d prime, so that's 3. Okay,